let's use the chain rule to solve for a derivative of some function of multiple variables when those variables are parameterized by a single independent variable. So I'm given w equals x sine of y, x is e to the t, and y is pi minus t. And what I want to find is I want to find this derivative of w with respect to t at the point t equals 0. So the first thing I want to do is I want to think about the formula that I need to make this happen. And so we have the derivative of w with respect to t is the partial of w with respect to x times x derivative in the x's derivative in t plus the partial of w with respect to y times y's derivative with respect to t. So what that tells me is I need 4 quantities to make this work. So let's go ahead and solve for what those are. And there's a little trick that we also need to do along the way. So we need to get the partial of w with respect to x. So if I take a look here, well, that function of y is considered constant, so we need to take the derivative of just the x. That gives us sine of y. Then we need to take the partial with respect to y. X is constant. The derivative of sine of y is cosine of y. And then the derivative of x with respect to t is here. The derivative of e to the t is e to the t. And the partial, or not the partial, but the derivative of y with respect to t, pi derives to 0, negative d derives to negative 1. But we need to be careful. We have all 4 of those pieces that we need to fill in here. But the issue is that at the end of the day, we want a derivative with respect to t. What I notice is I still don't have t's here. So I have to go further and I have to use these definitions to fill in. So I have to say sine of pi minus t. Which, if you do some trig formulas, is just sine of t, which is kind of nice. And if we plug in here, we get e to the t cosine of pi minus t. Again, if you use angle addition, or well, in this case, angle subtraction formulas, what you end up with is negative e to the t cosine of t. So now we have all 4 pieces defined in terms of t. So let's fill it in. So we need the partial of w with respect to x. We get sine of t times e to the t plus negative e to the t cosine t times negative 1. Keep wanting to write the partial there, it's not a partial. So we have e to the t here, we have an e to the t here, and those negatives cancel, so this is sine of t plus cosine of t. So that is dw dt, but we also want to find it at t equals 0. So e to the 0, sine of 0 plus cosine of 0. So, e to the 0 is just 1. And sine of 0 is 0. Cosine of 0 is 1. So our final answer, after all that, is just 1.